Hello, everyone. Welcome to the first episode of our podcast, Daring Debunkers. The purpose of this podcast is to debunk people. Today we'll be starting with our psychological studies. In this episode, Uncertain Certainty. I am your host, Ronald McDonald. Today we'll be talking about studies, specifically how unreliable studies can sometimes be. This was brought to our attention by an anonymous Good Samaritan. The study, performed by our honorary guests on our show, is truly groundbreaking. They will be discussing the results thoroughly for you folks' benefits. For access to the article we will be referencing, please go to science.science.org/content/349/AAC4716. And now, for our guest researchers, the authors of the article, will everyone please give a round of applause to Esther Morvay and Andrew Zhang. Hi, thank you so much for coming onto our show today. For starters, can you quickly summarize your study to the viewers back home?
Sure thing. Most scientists know that good experiments should have something called reproducibility, which is the ability to retain the same results if you repeat the experiment over and over. However, this idea is pretty subjective. For example, how close do your values have to be called close enough to the original value? And how important would it be anyway to get these close values? Our study aims to answer these questions and other questions. Essentially, what we did was replicate a whole bunch of studies from leading and reputable psychology journals and checked whether we got the same results from those studies that they got in the first place.
Absolutely fascinating, Easter. I'm shaking with anticipation. Can you clue us in on what the results were?
Well, we were pretty surprised about the results of our study. Get this, Chip, we only got close to original values for about a third of the experiments we tried. A third. Keep in mind, the original authors were overseeing us the whole time and were even giving us tips to improve our process. The mean effect size of the replication effect size, 0.197, had almost dropped in half from the original effect size of 0.403. Only 68% of the experiments were statistically significant.
That's kind of funky if you ask me. What can you tell us about the statistical significance of your results?
Well, it seemed to us that larger original effect sizes were associated with greater likelihood of achieving p is less than 0.05, or r equals 0.304, which is the correlation, and a greater effect size difference between the original result and replication, r equals 0.279. In analyzing the results of our study, we found several troubling and surprising trends. A negative correlation of replication success with the original study p-value, indicative that the initial strength of evidence is predictive of reproducibility. Interestingly, there was a strong correlation between replication and original findings on the basis of strength of their evidence. The median correlation was 0.57. Of course, this could just be because of random error or human error. But perhaps a reason for this could be p-hacking. Researchers want statistically significant results because then it's easier to get published in journals. So they may tweak the data.
That sounds terrifying. But how did you manage to tell if you deemed your answers close enough to the original answer? I can't imagine that you just looked at only one result or aspect of each experiment. That sounds too simple.
You're right on that one, Ronald. We assessed features of the original study and replication as possible correlates of reproducibility and conducted exploratory analysis to inspire further investigation. These included characteristics of the original study, such as the publishing journal, original effect size, p-value, and sample size, experience and expertise of the original research team, importance of the effect with indicators such as the citation impact of the article, and rated surprisingness of the effect. We also assessed characteristics of the replication, such as statistical power and sample size, experience and expertise of the replication team, independently assessed challenge of conducting an effective replication, and subjective self-assessed quality of the replication effort. In other words, we looked at a whole bunch of variables, standardized each one to fit in context. In other words, z-scores, averaged them, and compressed them into one simple index that we can use.
That's great, and what's that? Yeah. Oh, pardon me for a sec, but we've just received a word from our sponsors, Hunter Key Club themselves. Yes, one of the biggest leadership and service-oriented international clubs for high school students out there. They just informed me that because of the low amount of chocolate boxes that have been circling around this esteemed Hunter College High School, they'll be ordering another round of boxes. Yes, you heard it here, folks. Apparently, they've also employed their AP stats knowledge to change the quantity and distribution of chocolate flavors to better suit their customers' preferences. And to spice things up, they're going to be adding a new, limited, never-before-seen mystery flavor. This is groundbreaking news to us, folks. If you aren't satisfied with just their upcoming round of chocolate, then we implore you to come on down to join Key Club on Thursdays, Activities Room 333. Once again, that's Thursdays, Activities Room 333. Sorry about that, you two. Back to the interview. I kind of forgot where we left off. So, for now, can you tell the audience where you got the experiments from?
Alrighty, Ronald. First things first, we picked out some reputable psychology journals. We decided on Psychological Science, Journal of Personality and Social Psychology, and Journal of Experimental Psychology, Learning, Memory, and Cognition. All big journals in their fields. The first journal focused on general psychology, while the other two focused on social and cognitive psychology. We tried to make sure we covered on a broad spectrum, and not to pat myself on the back, but I think we did a pretty nifty job.
Good for you, Easter. But last time I checked, these journals easily contain hundreds of articles, each with multiple studies. How did you manage to pick out experiments?
Well, Chip, we couldn't just pick out any old experiment. First of all, we had to pick out collaborators who would actually do all of these experiments for us, and who had relevant expertise. Once we have our teams ready, we presented them with the first 20 articles in the first 2008 issue of each journal. For all you stats nerds out there, this is basically a random cluster sample. Each team would pick an article that suited their interest and expertise. Of each article, they would only do the last experiment listed, as the first experiments are usually some sort of preliminary demonstration.
Wouldn't the ability to choose lead to a selection bias?
We shared similar concerns in the planning stage of our study. However, because there are only 20 articles to choose from, and the fact that of whatever article they've chosen must match their experience, we believe that we eliminate selection bias. Furthermore, we only reproduce the last experiment of every article. The experts wouldn't know this experiment beforehand. Of the 488 articles in our sampling frame, 158 were eligible to be chosen, 111 were picked by the collaborators, and in the end, 100 were sampled due to constraints from time, money, and workforce. About 40 were chosen from the first journal and 30 from each of the rest.
It's nice to see some good sampling procedures for a change. What methods did you use to conduct analysis on the data you collected?
So all the indicators include p-value, effect size, sample size, challenge of doing the experiment, experience of the team, surprising effects, and subjective opinion. We then aggregate variables from many indicators, standardize and average into one index. We compare the indices from the original experiments to the reproduced version.
Well, what are some limitations of the study?
A key weakness of this method is that it treats the 0.05 threshold as a bright line criterion between replication success and failure. It could be that many of the replications fell just short of the 0.05 criterion. We also can only really apply this to psychology experiments. Everything else would be out of the range of this study. Furthermore, like we said, there is no concrete definition of reproducibility. We just put together as much aspects and indicators that we thought would be necessary and hoped for the best.
Well, even if there are some limitations to the study, I'm sure that you have taken great steps to create an even stronger foundation of the way we can conduct studies in the future. I'm afraid that's all the time I have for now, so once again, this was Easter Morvay and Andrew Jang. This is Ronald McDonald signing off, and I'll see you again in the next episode of Uncertain Certainty.